Hi guys, hope you are doing well. In this tutorial, I will discuss about the search performance using Redis, uh, Protobuffer and Bloom filter. Um in this tutorial, I will show you we have some example records like above 3 million unwanted domain, and we will do some search performance like we'll do using Protobuffer search performance. We will do uh, search using Redis, and we will do search using Bloom filter, and we will benchmark and compare which is going to uh, which is give us the best performance. We will see in this tutorial. Before starting the tutorial, now I am going to discuss about my new framework, Juno. Now it is currently developing state, and this is the framework URL. This is a PHP framework. You can see the documentation how we can generate a simple PHP application using this framework. You can check it, and if you like this, please give a star in GitHub. So let's start the tutorial. First of all, look at that. I have a two command. One is uh, process unwanted domain, and one is read unwanted domain. So this is the file read unwanted domain, and that I going to use to search a domain in our unwanted domain file. And this is the process file. This will generate a unwanted domain file from a remote server. So to download the file, I will use my company server and company's unwanted domain. So let's start the tutorial. So look at that. This is the unwanted domain. Some files we have already generated, like .json, .orc, .parquet, .pb, and .zip. So I did some search performance in this domain. So we have so many records, like above 3 million. So you will see how we can do some search performance. So I'm going to delete all of this file because I going to generate this from start to finish. So look at that. I deleted all the folder. I restored it. Now I just want to delete the unwanted domain, not app. So let's see. Okay, this is deleted. We will not going to delete this protobuffer, because using this file we will generate this GPB metadata protobuffer class. This is automatically generated from a protocol buffer compiler. To generate this class, we need to run this command, like this command, this kind of command. So I am not going to generate this. I'm not going to run this command because I already generated this class. So let's see. Now, first of all, we need a file to generate. So look, I am going to uncomment this, and this will just delete existing file. This is already I deleted. Download the file. Download this file means this will downloaded the file from this. So using this bunch, using this code, and then convert it to protobuffer. Look at this code. It will open the file. Then just using lazy collection, I am just in this domain to reduce the memory uses, and then sorting the domain, and then just using this to set it to unwanted domain, and then just returning this. This is the unwanted domain coming from this unwanted domain coming from this unwanted domain. So using this class, this is generated by Google Protobuffer, and after that, just processing convert to Protobuffer, set domain to Bloom filter. So we will do it later, and unlinked temporary file we are going to use this now, and then convert it, get converted Protobuffer file, and we need this. So let's see. I'm just going to run this method. So first of all, we are going to generate our protobuffer, because we will do search performance on this protobuffer file, and again we will search using Bloom filter, and again we will search using only Redis. So first we will search using Bloom filter. So look at that. I implemented Bloom in this services. Look at that. This is Bloom filter, Bloom manager, and there are bunch of code: helpers, factories, fetchers, contract, and services. And we have using the hash algorithm to set the big data, our unwanted domain data, to Redis. So we are using Murmur hashing algorithm. This is the algorithm I'm going to use to uh, store data into Redis using Bloom filter. For Bloom filter, look at that. This is the package Murmur hash. I'm going to use this algorithm. So now let's start the command. Process unwanted domain, and it will generate our .protobuffer file. So just start PSP artisan process unwanted domain, and look at that, download the unwanted domain. It is downloading our file from our remote server. Now it will just download a unwanted domain file, and there is almost 3.3 million records, and we will search a particular specific domain from the data. So, and we will check the search time, which will give us the best search performance. So it will take some time, like 40 to 50 seconds. It depends on the machine or memory uses. So take a wait for some time, and look at that, our unwanted domain, our text file is generated. So this is our temporary file. I'm just now reading this text file to convert it to protobuffer. You will, if you see the code, you will understand. Look at that. This is the convert to protobuffer, and before protobuffer is it. Now first I just converted it to Redis dot text file. First I converted it to dot text file, and then from dot text file I converted it to dot protobuffer file. So now it is converting to protobuffer. This is the protobuffer. We are opening this file, and using lazy collection we are just converting into protobuffer file, and we are going to delete this unwanted domain after the file is generated. We will unlink the file because we have already called this in our method which we are processing. So dot protobuffer file is generating. So just wait some time. We will just convert it for one time, because not every time we will generate it. For this tutorial purpose I am just showing you, and I will generate it just one time. So this will take 1 to 2 seconds, but I don't know why it is taking so many time. Let me see the code. Look at that, my protobuffer file is generated, unwanted domain dot proto, and it is taking 151 seconds. So I am just remove this comment, and look at this. Now if you see the domain, so I just opening this terminal from here, open integrated terminal from here, and if you run a command, look at that, this is our unwanted domain. We are just read from remote server this, and I am reading this unwanted domain from this file, unwanted domain.pb, and this is a protobuffer Google protocol buffer file, and this is a binary data, a binary format file. So I am just reading this file. So if I click this file, you will see there is like that. So I will take a domain. Look at that, I am taking just trykino.ru because we will search it, and I will take another domain like worker repeat worker. Let's take this domain only for test purpose. I am taking that domain. So we will use this domain, and another domain will be test.com. We will pass to parameter to search the domain. So now our protobuffer file is generated. Now time to push the data. Now we want to push the data to set to Bloom filter. Now our file is generated. Now we will just open this and commenting this and just uncomment it. Now we'll set our we'll set our unwanted domain to Bloom filter. Look at that, this is the Bloom implementation. We will fetch that unwanted domain from that unwanted domain file. Look at that, this is the file I'm calling, this is the method I'm calling, this is the domain, this is return a JSON encode array. So now one more thing to remember, that we are fetching the data from protobuffer file, not JSON or others files. So remember it. So I'm going to fetch this. This is just test purpose. I'm showing you how many record it's there. So just dump it and dump the count JSON decode, and just we're dumping so to see how many records is there. And now we will again run our command to process unwanted domain, and this time it will only call this method set domain to Bloom filter. It will store our all of the data to Bloom using Redis. So we'll check it and again just check our Redis CLI, how many keys is there. Look at that, there is no keys. So now I'm going to just run this command php artisan process unwanted domain, and look at that, starting processing of unwanted domain. And now this time there is 3.2 million records. You are seeing that 3.2 million records. So we'll search a domain, a specific domain from that kind of record. So just wait, we are storing our data into Bloom filter. So using Bloom filter, now just we are storing our data into Bloom filter. So wait a bit, I pause this tutorial. Now our data is stored into our Bloom filter. So let's see. Now time to check the search performance. So to search the data using Bloom filter, we are going to comment this code, because I'm not going to use unwanted domain processor. So sorry, this is a process file. We are going to use this read unwanted domain. So we are going to use this Bloom facet. So just comment this code, because this is a very sensitive. We will compromise every millisecond also. So again I'm going to comment out this parquet file system, because in this tutorial I'm not going to use parquet searching. So our parquet file is commenting is completed, and also our constructor code is comment completed. So now I'm going to search this. This is the key I used to store data into Bloom. Just check there. I just use this unwanted domain. This is the key, and this is the every domain I just store this against this store this domain for this unwanted domain. This is the key, and this is the data for this corresponding domain for this key. So now I'm going to search the domain from here. This is the parameter we are going to test either that the domain is there or not. So if domain is there, it will return boolean true, or if not, it will return false. Though Bloom filter return the false positive if there is no data. You can study about Bloom algorithm, so you will get the result, and you will understand how Bloom filter work and how this algorithm works. So please, before seeing the tutorial, read the theory about the Bloom algorithm. So now we are not now I just want to run this command. I will run 3 or 4 5 commands, so and take the minimum second which take to search data. So before checking the data, we have to sure that our data is there. So just check the Redis cache. Look at that. Last time we checked key is all and there is no keys. Now I am checking again, keys all, and look at that, there is a Laravel database unwanted domain, and there is 30 million records, 32 million records, and this file size is 86.2 megabyte. That's massive, I think. So and there is 3.2 million above records. So now just check the memory sizes, memory uses of this key. Memory uses, maybe the command is like that. Sorry, I just doing Google Redis key memory uses. The command is Redis. The command is Redis CLI and info memory uses and memory uses. Sorry, I uses perfect right command, but spelling was mistake. So again running the command memory use s, and the command is, and the key is, look at that, our memory size is 146,802. If we convert it to megabyte, and it is approximate 14 megabyte. This is very very low. If you use, cause we are using Redis, we are storing the data into Redis using a hash algorithm. If we see the data, just I'm seeing you how we can see the data using for this key. Just if we write this, it will show our data. Look at that, this is the our data, and that is the hashing. You are seeing this is not the plain text or plain domain. So we are confirmed that our data is there. So now we can check our data. So just I am running the command. Look at that, I am just zooming it to show you PSP artisan, and we will run the command is read unwanted domain. So there is already a domain which we are going to search, and that is you are seeing the spelling is pronunciation is very tough, I think. So now I am running this, and this is the search time of 0.0047 second, and that is found. That means the domain is there, and again we are going to use this domain, and again we will run the command. It will also found, because we are take this domain from the that set of data. You already know that. Now I am going to use another domain that is not there, and that is test.com. So if I run this and not found, yes, our Bloom algorithm is working in our Laravel system, and that is the minimum search time is there. So I am taking this. This is the approximate search time for Bloom algorithm. So I'll just remove this, and using Bloom algorithm, search time is this. And now we are going to back to our Bloom searching is completed. Now we are going to search using Protobuf by reading Protobuf file. Direct we read this data, and we will search from this binary data. So just git reset hard and git reset hard, and our domain, we are still getting this data and just deleting. So now look at that, our Protobuf is there. So that is enough. Now I am going to just checking out our master branch, and Now I am in master branch. I am in master branch and check out master branch, already on master. And now there is some different type of codes. And look at that. This is different type of code you will find here. We will not going to run this code. Now we will search data using uh, binary data. So there is a binary file. This is from binary file. So just comment out this and uncomment this. Get data for binary file. If we run this, see this code, this is the domain we are getting. Just merge from string. This is the method from Google Protobuf built-in method, and just get domain. This is from the method from here, and this is the generated class from Google Protobuf compiler. Look at that. This is the generated by protocol buffer compiler. Do not edit. There is a text. So now we are going to search using protocol buffer. So let's see. There is a domain and search domain. One more thing is that I just implemented a binary search algorithm to search. We can use in array. Look at that. This is the domains array and this is the key we are going to search. So we can use in array, but there is a huge limitation. We are going to search 3.2 million records. So in array is not going to give us the best performance, because in array will give us the minimum second also, but in array uses so much memory because in array uses linear search algorithm. So it takes more than big memory. It uses big memory than binary search. So binary search uses very low memory. So you can study about binary search algorithm and linear search algorithm. So I am going to search this using this binary search algorithm. So using binary search, we are going to search our domain from this protocol buffer file. So just look at that. We start our microtime, and in microtime after the search result, and we will just fetch the data from this method, and then we will search our domain. So before to search the domain, we have a domain. There is domain. So let's see. Maybe domain not found issue is there, because this is the another file, because we are in master branch. If there is something wrong, we will again generate this file, no problem. So again just read the domain. If we search using protocol buffer, look at that, the time is 0.741 second. The time is 0.741 second. The time is, look at that, 0.9, and the domain is not found, because the file is generated using this is the another file. So to get the data, we can generate this file again, but I'm not generating because it will take some time. So just you know that this is the master branch, and this file is a master branch file, so the domain can mismatch. So again I am using this domain to search the data. I am just checking this, and if I run this, look at that, this is also not found. And if I back to this domain, look at that, this domain is found, because this domain in this file. So I am taking this again I am running twice to check the search performance. 6.6 and 0.7, this is the minimum time, so I am taking this time as a search performance using binary. So using binary, using protocol buffer file, the search time is this second. And now time to search using Redis set. So we are going to search using Redis set. So using Redis set, we have to store the data into Redis set extracted domain and put to Redis. So we are not going to convert to ORC, not JSON, not Parquet, not protobuffer, not download file, not delete existing file. We are just going to set it to Redis and converting unlink the temporary file. There is no temporary file, so there is no need to call this, and get the converted file. And now convert to protobuffer, no need to method. And there is method to set extracted domain to Redis. Now we are going to get the domain from data, and we are going to connect the Redis, and then we are going to set our unwanted domain using this key unwanted domain and the domain from unwanted domain. And just we are going to use Redis set sys member. They are just not normal set get. This is the set, another Redis built-in implementation. Now I'm going to use as there is so many domain like 3.2 million records, so I am going to use Redis pipeline. And now you are seeing that I am going to use this Redis s add to bash process, and I am going to use the s add. Look at that, there is some theory using this, why I'm going to using s add, because it this is the only reason I'm going to using this Redis s add without accepting Redis set hash to Redis. We can also use a Redis hash or normal Redis set, like set Redis hash set. So there is three options: set Redis set hash, or you can use Redis s add. So I am going to use Redis s as why? Because to search using Redis s as, we do not need to fetch all the data before searching. This is the main reason. Using Redis s add, if you want to search the data, if you want to check that there is your key exists or not, there is no need to fetch all the Redis data before searching. That is the main reason. So let's see, you will see that. So now I am going to store the data or data into Redis cache. So before putting data into Redis cache, we again remove all the Redis data. Look at that, there is no data in Redis right now. So now we are going to store our data into Redis, and that is the method Redis. That is the method we are already calling this. You are seeing that we are calling our main process file, and we will just set it to Redis. And to store the data into Redis, there is a format, and that is, we do not need JSON encode, and just return the domain, and using array slash, and just return the yield domain. That means we are reducing our memory uses using this yield, and it will return iterable, not array. So now our domain facing part is completed, and there is another option, that is look at that, I am using s file object, not using file get contents. So if you use file get contents, no problem, it will also face your data, but it uses one time very big memory uses. So I am just avoiding it to fetch the data. And if you use SQL file get object, it will fetch your data lazily, like one by one process your data, and it will reduce your memory uses massively. So you can test it in your localhost. So now I am going to get unwanted domain, and if I get unwanted domain and just connect the Redis, and so process the domain to store the data into Redis cache. Now I am processing data, process unwanted domain, and it will store the data to Redis. Now it is storing the data into Redis, so it will take some time. So I am again look at that, the 5 second is take, and if we our data is now in Redis set. So if we check the keys again, look at that, the keys is not there. And if we select a database, and if we again check the data, and look at that, there is protobuffer unwanted domain. And if we check the data, so how we can check this data? And there is a command, there is not if we use the command get key, look at that, it is not going to work, because we used to set our data using s add. So there is different command, and that is the command sys member Redis unwanted domain. And if we run this command, you will see our data is set. just wait a bit, it is processing. Is member protocol buffer unwanted domain, that is our domain key, and yes, that is the domain key. And look at that, that is the domain we are set in our Redis. And look at that, this is going to stop after 3.2 million records. Right now it is 23, 24, 25, 26, 27, and done. 3.2 3.2 is come, and now our the domain is set. And if we check the domain, just that is the command s member your key and your searchable key. I'm just going to use this to search the domain. Now if we are going to search a domain using Redis set. So just check how many time going to take using Redis. So read unwanted domain, and we will domain the data so using Redis. So there is no Redis implementation is there. WRC file, binary file, JSON file, we no need this domain. So if we going to search the domain using Redis, so we are going to use Redis class, and there is a check method. There is of course a check method. So get sys member, look at that, that is the method get. We already used Redis asset, so we are going to use this get sys member. There is a sys member exist or not. This will give you all your data, and if you check exist, there is a key in Redis set. We use this method. So just we are going to use Redis, and using this we just pass the domain. Exist in cache, and we are just going to pass this key and our domain. Our key is unwanted domain, protocol buffer unwanted domain. Our key is protocol buffer unwanted domain. So we are going to pass this key, and that is our domain, our searchable key that is there, and this is our key. Look at again, check the method. This is the searchable key, and this is the our key that we use to store our data into Redis. And now our micro time is start, and we will get the data, the domain is there or not. Just use this, and there is no binary search, and just found or not found. Okay, total domain is not there, not necessary. Now just run the Redis set to check domain and read the domain. We are facing some error. Redis must not accessed before initialization. Sorry to say that we have to connect our Redis. This connect Redis, and our Redis connection is done. And again we are going to run, and look at that, boom, there is look at that, there is getting the very minimum second. This is the minimum 0.555. so this is 3030, and every time 30, so there is 20 using Redis set algorithm. The searching time is using Redis set algorithm. The searching time is, that is the searching time. So we are pasting it. So now again we are going to test another domain, and that is this. And if we check it, look at that, this is again, this is taking the minimum time. So now you can check that there is 0.004 using Redis set algorithm. Using protocol buffer there is 0.066 second, and using Bloom algorithm there is 0.00471 second. So there now our tutorial part is completed. The main part is completed because in this tutorial we used Bloom algorithm and protocol buffer and Redis set algorithm to check the specific domain in a unwanted domain file, and from Redis and from protocol buffer and from Bloom algorithm. So you can check it in your server. And if you like this tutorial, please share it with your friends, and please like it and share your thought. If you have any question, so you can ask it and in the comment box. I will try to answer and try to uh, I will try to help you. So thank you so much.